So then let's start with our session. Again, welcome to our webinar Fit for FOGRA 51 and 52. Few words about who is speaking today. My name is Jessica Landherr. I'm responsible for the Academy here at GMG, and with me today is my colleague Jürgen Seitz. He was involved in the creation or in the testing and developing of FOGRA 51 and 52. And yeah, us two will tell you some more details about the new characterization data sets today. Let's have a quick view on the agenda for today. We will start with the evolution of characterization data. We will have a closer look on the new criteria, talking about what has changed in viewing conditions, what has changed in our measuring conditions, and what has changed in our ISO 12647-2, so our offset printing standard. We will have a close look on the new characterization data sets, FOGRA 51 and 52. We will talk about proofing papers containing optical brightness, have a little wrap up at the end, what this means for you in your work environment, and at the end we have time for questions, answers, everything which comes to your mind. Okay, then let's start with our first topic, evolution of characterization data. So you see here the characterization data sets FOGRA 1, 11, 27, 39, and FOGRA 51. All these characterization data sets are actually based on the same printing condition, or they describe the same printing condition. This is offset printing, coated paper, standardized inks. As you see here on the slide, FOGRA 1 was based on one print sheet. So this is why we see these irregularities in the measurement data. They took one print, measured it. This was the characterization data set. Standardization hasn't been as developed as today when FOGRA 1 was established. That's why no target values for the primary colors had been taken into consideration and no TVI curves back then. FOGRA 39, so ISO-coded version 2, actually is the first characterization data set in this row, which is based on the evaluation of multiple printouts. So by this characterization data set, FOGRA 39, is an optimized and harmonic characterization data set respecting the TVI curves and primary target values. Okay, so when FOGRA 39 isn't that bad, why now do we need FOGRA 51? What has changed? What changed is our reference, and the way we measure our reference changed, So it's all about the OBAs actually. OBA stands for optical brightening agents. OBAs are fluorescent substrates. For instance, in detergents, you recognize them, or when you go to a club and your shirt is all shiny. In all of these areas, we have the OBAs involved. And in our production printing papers, the usage of optical brightness is very common as well. So optical brightness are now easier to determine, and they are respected in our processes. So we see this in the following topics: D50 as our reference for viewing, proofs and prints, the new measuring mode M1, and the new revision of ISO 12647-2. We will have a closer look on these three topics now. So let's start with the changes in our viewing conditions. ISO 3664 describes criteria and tolerances for color appraisal under D50, such as color temperature, the surrounding, anything you can imagine. In the revision of 2009, One value has been revised to be more critical, which is the metameric index for UV. You see the red circle on the screenshot from the ISO standard. The metameric index for UV has been changed from 4 to 1.5 in the new revision. This index describes 3 different fluorescent test patterns, as you see on the right bottom here, with their non-fluorescence correlate if viewed under D50 light. So under norm light, these 3 test patterns should look the same. The difference between these test patterns is measured in delta E, formula to describe color differences, and now with the new revision, the 2 test patterns can have a deviation of 1.5 instead of 4, which was the former value. If the norm light matches D50 100% completely, the resulting delta E and so the resulting metamerism index would be 0. Okay, so this reduced metamerism index results now in a higher UV content in our light bulbs. And this higher UV content has an influence on the optical brightness in our production paper, since the OBAs are excited more and more visible now. We have some examples. So here we see the situation we had before the norm revision. On the left, we have a proof, for instance, FOGRA39, on a proofing substrate with without optical brightness, next to a production paper containing optical brightness, as it's in most cases represented. And we see a pretty good match before the norm revision. So what changed now is our light. So the light bulbs we use in our viewing booths changed with the new revision. They have a higher amount of UV. We see the difference. I will switch back and forth so you see better. So old light, new norm light. We see the proof is nearly the same. It does not really change, but the production paper on the right is brighter and more bluish. This is because the OBAs, so the optical brightness in the production paper, are excited more due to the higher amount of UV in the light. So actually our proof is now too yellow in comparison to the print. So what to do, since our proof should simulate our printing situation? We have to adjust our proofs. Here we see still the new norm light situation, but on the left the proof changed. So there has been new characterization data used, and the proofing substrate contains optical brightness now as well. This is then the perfect situation to simulate the brightness and the paper tint of the actual used production paper. Now it's getting a little bit mathematical. Our colleague Hanno Hofstadt has built this graph to explain more precisely what the changes are with our norm light. So this graph is built on the OBA reaction in the papers. The blue point in the middle shows our D50 reference. And if we go from there to the left, we have less UV down to UV cut and more UV to the right. The red line shows how the OBAs react to less or more UV content in the light. So with less UV on the left side, the B value goes positive, as you can see, which means more yellowish. And with a higher amount of UV, this optical brightener reacts with a negative B value, which means the paper tint gets more bluish. The yellow frame we see here now shows the tolerances of the UV metamerism index from the old standard with 4 delta E, and the green frame describes the new revision from 2009 with a new tolerance of 1.5. So you see, it's a pretty big change actually. The light of different viewing booths has been measured. On the left, we see the older booths. We see they are all pretty close together, but pretty close to UV cut. So actually, in our old condition, optical brightness has not really been measured or seen, since the optical brightness were not exaggerated, excited. The newer booths, which are all inside of our green rectangle, so they are all inside of the new tolerances, are now very much closer to our D50 reference, as you can see. These measurements were some of the first batches after the standard revision, so today's light bulbs are even closer, moving closer to D50, so to our actual norm light reference. So for comparison, we see, it's in German actually. So I'm sorry, on the left, this pinkish area, you see typical no filter measurements. And from measurement devices, and in the middle, right on D50, you see typical M1 measurements. We will have a look at this later on again when we talk about M1 as a measuring condition. So you see the spread between the different measurement devices has been bigger with no filter measurements, and we are now closer to our viewing booths with the measurement mode.
May I add one sentence here?
Sure.
So the no filter measurement in the past had no definition for the UV content. So we will touch that in a minute. So the no filter measurement was not defined, really well defined. This graph just shows what we have found out, what typical no filter measurement has shown as a kind of spread, while M1 measurement is very much in the center, or very well aligned with the reference of D50.
So, yeah, then, okay, to wrap up everything about the viewing conditions, of course, we should avoid to use the old light bulbs. Actually, since 2011, there are no older light bulbs, so no light bulbs according to the old revision available anymore. We saw that the new light bulbs have a higher UV content, so the optical brightness are now excited more. But the good part is, or the positive side is, that we are now closer to our typical daylight, or to our daylight reference D50, and we are closer to our D50 measuring devices. Of course, we see we have to adjust our proofs to simulate this situation, ideally. Then let's jump to the next topic, the new measuring condition M1. So in accordance to the new revision for the viewing conditions, we have a new revision touching the measurement conditions. ISO 13655 describes these, and the most important change in this revision are the 4 newly defined measurement conditions. So M0 describes the legacy mode. This has been the former no filter measurement mode. Jürgen already mentioned we had no defined UV content here. So when you measure no filter with one device and no filter with another device of a different vendor, the UV content in the light must not have been the same, since we had no rules for that actually. This is why we have the new mode M1. Here we now have a precisely defined UV content, and we are much closer to D50 now. M2 describes our well-known UV cut mode. Actually here nothing really changed beside the name. And M3 describes the measurement with polarization filter, which is as well defined as a UV cut measurement. So it includes an M2 mode actually. So just to get a feeling for the differences between the measurement modes and the influences in our measurements actually, here we see a remission curve of an optical brightness containing paper. We measured with M0, which is the green line, M1, which is the red line, and M2, UV cut, which is the blue line. When having a look at the M2 curve, we see there is no UV content in the light of the measurement device. So we see there's no excitement of the OBA. How do we see this? We see this because there's no emission of bluish light. So in the wavelength area of 420 to 470 nanometers, we have no emission of the bluish light. This is where you can tell that optical brightness are in the game, because optical brightness absorb light in the UV area and send it out in the bluish area of the spectrum. When we then have a look at the M0 curve, we see that the OBAs are partly excited, but it is important to remember the UV content is not defined for this mode. So when measuring this paper with a different measuring device in the same mode, M0 no filter, it may be that the excitement of the OBAs varies slightly, since the UV content is not defined. And then we see for M1 we have the highest excitement of the optical brightness. So as rule of thumb, you could say that the excitement of OBAs for M0 is round about 70% of the M1 mode. This is the corresponding AB graph to this measured paper tint. We see the highest difference between the measurement modes in our B-axis, so in the bluishness of the paper, so to say. This is caused by the optical brightness. So the M2 measurement is almost neutral, and then we see when we measure with M1, we have minus 5.6 or something, so a more bluish value than measured with M0, where we have a value of minus 4B. So this is again the chart with the viewing booths compared to our typical measurements. So we see the spread between the different no filter measurements is significantly higher than for typical M1 measurements. And the very good part is that the M1 measurements now lie directly on our reference D50. So our measurement in M1 now totally corresponds to our viewing condition we have. So of course, these changes affect our work when working with optical brightness. M1 aligns very, very good, or aligns almost 100% with our new viewing conditions. So we measure what we see, finally. And of course, for substrates not containing optical brightness, in theory, it is M0 equals M1 equals M2. That was the same before. For substrates without optical brightness, the no filter mode equaled the UV cut mode. And this is as well a method you could check if your substrate has optical brightness. Just compare a measurement between M1 and M2. If there's a difference, you have optical brightness in your paper. There will be, or future characterization data sets will be defined in the new measurement mode M1. Some data sets already have been released, defined in M1. These are listed here. So we see Gracol and SWAP 2013, which are mostly used in the US, are defined in M1, as well as FOGRA51 and FOGRA52, the data sets we are talking about today. So FOGRA51, the official name is PSO-coated version 3. This is the successor of FOGRA39, ISO-coated version 2. And FOGRA52, official name is PSO uncoated version 3. This is the successor of FOGRA47, so PSO uncoated. There are already a whole bunch of measuring devices in the market supporting these new measurement mode M1. We listed them here. Several X-Rite devices, Epson embedded devices, Canon embedded devices as well, so the printer embedded spectrophotometers, SpectroDance, Konica Minolta for the printers. In our software, we support the i1 Pro version 2, we support the ISIS version 2, Epson ILS 30, and the Canon embedded devices. SpectroPad is supported as well. SpectroDance obviously does not make so much sense to do profiling with this. And of course, there will be more measurement devices supporting the M1 mode to come. So, Jürgen? No. I thought you had something to add. Yes.
I just lost the sound. Sorry.
Okay.
It's okay.
Good. So we just heard the changes in our view.
Here? Shall I take over here a part?
If you want to.
Okay, let's go. So we've now heard about the changes in viewing condition, which is now a better alignment to an average daylight condition described as D50, our all reference for all standards in prepress and print. And we have heard about the measurement devices that are now super well aligned with the viewing conditions. So really, from my personal experience, I can really tell that we've never been so close with measuring what we see and see what we measure as of today. As a logical result, after all these changes, it's obvious that the description of typical production paper and typical printing targets as described in the ISO 12647-2 for offset printing, for example, is not valid any longer, at least when it comes to optical bright substances. Maybe we jump into. In 2013, finally we had the revision ready for 12647-2. Beside of the OBA and M1 related topics, there was some topics change we will just jump into. But basically, to describe what this standard describes, it's the printing conditions and the printing references and the TVIs and the solids for different paper classes in offset printing. What is changed in 2013? We have a new number of printing conditions. From 5 paper types in the past, we have now 8 paper types described, 4 coated and 4 uncoated paper types. You see the list of paper types here. which goes from premium coated through the list of coated to wood-free uncoated and the other uncoated guys. As well as these naming, this revised list of printing papers, we have now the M1 definition for the paper tins described in AB, and new kid on the block in this list is the fluorescence level. We never had any indication for typical fluorescence level of printing substances, printing papers. This is now given. On the bottom of this slide, you will see the fluorescence limits, the typical tolerances. So 0, you see faint is 0 to 4, low is 4 to 8, moderate 8 to 14, high is 14 to 25. So if you don't know what this means, this is a number of delta B. A delta B is measured in the paper industry when they measure with D65, so they have a very sensitive paper measurement, and they measure a B value, a B star value from an LAB with a lot of UV content and with UV cut. And the difference between the two B values that they measure with their typical D65 measurement devices gives us a spread up to 25 delta B. If we would measure a delta little b, it's called, between an M1 and an M2 measurement, so we have seen earlier on this one paper, we've seen the delta between an M2 UV cut and an M1 D50 measurement, and we already had something like 5. So the spread of the results measured between M1 and M2 would be something like maybe 14, 15 max. Okay, but this is just as a background information. Let's continue with the next slide. The other change in the ISO 12647-2 is the description of a typical TVI curve of a linear plate. ISO 12647-2 tries to describe an offset printing process as it would behave with basically almost no modification. So you print on a machine with a linear plate with ISO compliant inkset CMYK. In the past, the description of the TVI curves was affected by still having film copy and stuff like that. Now the new shape of the curves, you see here the lowest curve is the red one, is the old curve A versus the cyan one, which is the new curve A. So we see that the new definition of the typical TVI curve in the offset printing process shows more importance of a dot gain in the quarter tones mainly. One other important aspect that has been modified from further versions of the ISO 12647-2 is that now we describe C, MY, and K to have the same TVI curve. In the past, there was always the black channel described to be higher with its TVI than the other process colors, which was mainly caused due to the derivation of the black channel as such. So K stands for the German word for contrast. In the past, black was just used for text and contrast and images, historically seen, so really in the past. But nowadays, black has become an important part of the process colors, so it has to be managed and well kept and treated like the other process colors, and that's why it just makes sense that to have K as the CMYs on the same description in TVI. Let's go next. One other topic which will most probably become more important in the future and which opens more flexibility is Annex B of the ISO. In Annex B, which is just one of the annexes, there's a description that characterization data can be modified. So if I, for example, have a FOGRA51, but the paper I'm printing on is not really looking like a FOGRA51, but maybe much bluer or more yellow, whatever, you can take the FOGRA51 characterization data set and use a formula like, as an example, the one from NXP, or use better the GMG paper adaptation tools formula to modify or to preview how a printed result will look like if printed on this different paper shape. This is an important task because in the future we have now really all the tools on board to measure paper and to adapt a pre-press and a proofing process very precisely to an achievable printing result. So the accuracy of an average print-to-proof match will improve dramatically during the next years, partly because of these tools now coming up, partly because of just the much better measurement viewing correlations.
We have a question. I think it fits in now perfect. Does the change of TVI curves come from the different measurement conditions M1 in the new ISO? Actually, the change in the TVI curves is because they are now representing a linear plate creation. So the step of film copying is skipped. This is why the TVI curves changed.
Yeah, it's the CTP. In the past, it was CT. So the last revision of ISO 12647-2 was trying to an average basically between film copied plates and CTP plates, while now we just don't see film copy any longer, and this reflects the typical reaction of a CTP plate. But please be aware that these TVIs just describe something like an average that has been developed or that has been measured. But with every screening algorithm, you will have slight, and with every manufacturer of plate, with any kind of plate, you will have slight differences. So still a plate curve will be needed to bring your plate in your process to fit to the given reference. Okay, we can continue. So now we have new measurement, we have new paper categories, we have new target values in the ISO 12647-2 describing the offset printing as such, and we still had FOGRA39 and following up with all the other guys. FOGRA39 describes old TVI curves. FOGRA39 was created with no filter measurement devices. FOGRA39 was basically tweaked to match with its paper tint under old viewing conditions. So several parameters in FOGRA39 just don't fit our today's working practices. A FOGRA39 proof on an OBA-free proofing substrate does just not fit a typical production stock under new norm light. New characterization data sets FOGRA51 and 52 have been carefully developed. So we first looked into what are the most important printing conditions from the new ISO 12647-2 to be renewed. Of course, all of the 8 printing conditions described in 12647-2 will have their characterization data sets, but the priority number 1 was seen to be on premium coated and wood-free uncoated papers, which already today are basically some kind of standard for CMYK data handling. And these are the 2 guys where the M1 effect is the strongest. So the mismatch between yesterday's FOGRA3947 proofs and a given production stock was just not accurate. FOGRA51 has now been described on a paper tint of 95 1.5 - 6, as you see on the bottom. This is an M1 LAB target value, and the FOGRA52 has been defined 93.5, 2.5, minus 10. These are both not values that are described in 12647-2, but these are both values that we have, together with FOGRA and ECI, have developed to be the best average candidate value to deliver a best average match to a typical production paper. This is an example of some measurements we've done. On the left side, you see some orange dots which are target values measured in LAB from wood-free coated production papers. On the right side, you see wood-free uncoated paper. Let's see the left side first. So we measured with M1, we measured with many different M1 devices to get this captured as well. We measured M1, the different stock. You see on this graph, the vertical line shows the luminance, the lightness of the substance, of the substrate, and going from the right to the left, it's getting more bluish. We have some very bluish ones on the very left, but then on the wood-free coated papers, we can see that between 6 and 7, minus 6 and minus 7, there is really a bunch of papers. And in fact, we've seen that the majority of wood-free coated papers can be found in this area. Now you see the FOGRA39 M0 target value at the -2. That's where FOGRA39 simulates a stock on a proof or on a soft proof. You can see the green dot which describes the target from PS1, how the printing substrate 1 is described in ISO 12647-2 2013. So considering that from a practical experience, FOGRA39 was basically always too yellowish, and we have this change from M0 to M1, we then researched, okay, a FOGRA39, if it's -2, if we would measure the same paper with M1, it would be close to -4. Okay, but the most of the papers are -6, so we defined this black dot to become the FOGRA51, which is now not beta, so we have to type this out, I just see. So this is the FOGRA51 target. If we now look at the wood-free uncoated papers, the same happens here, even worse. On one hand, for the wood-free uncoated papers, we don't have such a grouping of typical paper, but we have a huge cloud. And it's not only this purple dots here, it really goes on the right side. If we go into book printing, we have a lot of papers being +2, +4, +6. So the uncoated paper cloud is much, much wider. But we have significant problems, issues in proofing of higher OBA papers. So we moved the FOGRA47 from PS5. You see this move where FOGRA47 was basically moved to a new target in M1 to something pretty much, to a pretty much different location. Just to cover, you see this circle, to cover within a delta E of at least a lot of given production papers. Most probably right now in discussion with FOGRA, in discussion with the printers, we are considering maybe having at the end more FOGRA, more candidates or more characterization data sets for this PS5, for this wood-free uncoated paper class, because the book printers, they will need a characterization data set on the yellow side. Some papers are more neutral, but with FOGRA52 to start is really a very nice adventure. I really love it to see the perfect match that we today get doing a FOGRA52 proof in front of an uncoated printing production. So what we can say is that colored communication using FOGRA51 and 52 is getting much better in front of whatever kind of standardized process. Even though, when we started with the viewing conditions, which have been revised, and everyone should have a viewing condition that is according to the ISO norms. But we still have customers maybe going to the window and taking the daylight as their norm light. Even then, we have a real improvement now. FOGRA51 describing OBA papers as they are, as blue as they are, and the typical daylight, even at the window, for example, would excite the optical brightness in papers. And as this is already described in FOGRA51 as well as in FOGRA52, this is a really quality, a big step forward in quality of color communication in pre-press and in the press room. We have really worked from scratch building these data sets. At the end, it is, let's say, something like 80% of the work for the LAB values was done with GMG technology, with our open color tools, with our tools where we analyze spectral data, spectral measurement data, and we smoothen and linearize and bring them to a target. Yeah, it's to say maybe just this one point. Even though FOGRA51 and 52 are not spot on with the paper target values as described in the ISO, they are conforming to ISO as they are just basically moved with a formula. So for the printer, there's no change, just the proof matches better. And the printer at the end will print basically the same density as he did before. The standards are the standard ISO 12647-2 still describes colorimetrical aim values, target values, but at the end, this ISO 12647-2 just describes a paper-specific ink layer thickness on the given substrate to typically reach a specific LAB color value. But for the printer using the new norm on his machine, he will basically have only minor differences in driving the densities of cyan, magenta, yellow, and black. Which is more important for the printer is to have a new plate curve, to have CMY and black aligned, and to reflect the higher importance of the TVI on a quarter tones. Now we can continue to the proofing substrate. For us, the final logical step was then to develop an OBA paper finally. There was a challenge like light fastness. In the past, it was a kind of rule that a proofing paper has to be OBA free because OBAs, once they see the light, they will just disappear. This was not really true. And we have learned how to create substrates that are stable, that have a light fastness that is really strong, to build in the OBAs into the substrate, so the OBAs are kept in a stable environment, basically are stable built in. And, the challenge then was to have a good comparability to production paper. Just making an OBA paper does not mean that then the fluorescence level, how strong is this OBA reacting to UV light? Is this comparable with an average production stock? There was a lot of evaluation going on until we had our average level to be designed in our paper. And then to find an optimum paper tint. Jessica, do we have these pyramid graphs later?
Yes, for sure.
Great, good. I was not sure if we have it in here. So what the benefit we see was really that an OBA paper in front of a proofing paper in front of an OBA production paper just enables much more accuracy in proofing. So whenever the viewing condition is not optimal, whenever you have a window nearby, or maybe someone has a light booth with a UV cut screen or with whatever kind of different bulbs in, whatever changes in lighting conditions that are UV related, the appearance of an OBA proof would change much closer to what we see on a printing paper. We had to make sure to cover the different printing papers, and that also was much easier with the development of an OBA paper. Okay, on this we can see a little bit. So we took the GMG SemiMatte 250, and if you look at the GMG SemiMatte 250 OBA, you will basically look at somehow the same paper. It's just that the coating on this paper contains the OBAs we need. So we have a paper tint in M1, which is very comparable from its luminance level to the GMG SemiMatte 250, just that now we have the almost -6 on the -B. When we've been at -1.7, 1.8 on a SemiMatte 250 without any fluorescence. Now we have a fluorescent paper describing fluorescent printing substrates. From the two graphs we've seen before, we've collected the different paper tints from coated and uncoated production papers here. And you see the two dots now, the FOGRA51 and the 52. And the gray pyramid describes our GMG SemiMatte 250. So SemiMatte 250 is almost at 97 L and somewhere around 1.7 minus with the B value. Now, it's just a physical fact that if you want to simulate another paper tint on a proofing substrate, that what we do every day, you either print more yellowish or more bluish. So if the pyramid going to the right hand would simulate more yellowish paper, printing yellow ink on a proofing substrate does not cause a big issue in luminance. So I can simulate delta B of 10, so 10 B more yellowish paper, and I will not be very dark with this paper simulation. But as soon as I use cyan and magenta ink on my proofing substrate to simulate a more bluish paper tint, I lose significant luminance. So I'm getting darker. And that's what this pyramid shows. So this pyramid shows that for every B I want to be more bluish, I lose something like 0.6 to 0.7 in L. This means that with this pyramid you can see that there are many papers that are just out of gamut. We cannot simulate all these points, all these printing substrate production papers that are out of this gray pyramid. On the GMG SemiMatte, this is just not possible. If we now continue to the GMG SemiMatte OBA, we see that on the same luminance level, on L97, we've just moved to -6. And now we can simulate much, much more of the different printing production papers. This was an important step forward for us. So this, beside of the fluorescent effects that we are really taking into consideration with using an OBA proofing substrate, this, beside of that, gives a huge advantage in using OBA papers. For my personal guess would be that within a year we will have at least half of our users using OBA paper, and I see a lot of agencies or prepress companies that are typically handling jobs for coded or uncoated to 80–90+% to be at the end printed on production papers that contain OBA. So to switch completely to OBA proofing substrate, as this just makes sense. As mentioned at the very beginning, stability was a task, and the FOGRA has developed nice testing methods to describe and to verify the stability of OBAs in papers. It was interesting to see that some of the tests showed that this paper is more stable than the proofers' inks sometimes. But the tests, they are exciting, the paper tools are really strong, so they have a UV sun tester, so that's a very strong UV lamp that runs then maybe 2 days, which stands for something like 2 years of an office environment that is simulated within these 1-2 days, and the paper then has to match still within a very tiny little delta E tolerance before and after, measured before and after. So this was our OBA paper, was the first certified OBA proofing paper, and yeah, we have it since a year now, and it's really now having 51 and 52 on the ground. Finally, this is already it already started successful, but now it's really going on very quickly. I heavily recommend test it. I heavily recommend just use it. I heavily recommend, even though you maybe still proof FOGRA39 because most of your customers are still delivering FOGRA39, make a FOGRA39 proof on an OBA paper and you will see how big already there, even though it's still a yellowish simulation, how big the advantage is of having this fluorescent effect on the proof as on the print. We just got a question here, when is Adobe implementing 5152? So for screen proofing, so downloading 5152 is www.eci.org, I think it is. So there you can find the PSO coded and the PSO uncoded ICC profiles. These ICC profiles provided by ECI are based on the FOGRA datasets. On the FOGRA homepage, which is www.fogra.org, so ORG, there you can find in the download area all the characterization datasets from FOGRA. When you use it for screen proofing, it's PSO coded, use the ICC profile and do your screen proofing, so the soft proofing on a screen, that's already there. In the beginning, the guys from the soft proofing arena, they were very reluctant because they did not believe that this bluish simulation on a screen would really fit, but they were struggling because their normalized that they took beside of their screen were not M1 alike. So having a very old norm light beside of the screen, which is almost UV cut, and then having a screen simulation of a bluish paper tint like 52 with -10, that really makes a big visual difference. But the ICC profiles are provided by ECI, are there, use it. We are having the setups ready with 51 and 52 for color proof and color server for all the conversion, 39 to 51 and so forth. Adobe, I think, should already start now implementing. I don't know exactly when they do. I've just met with some of the Adobe guys, but this was unfortunately not the discussion about. But this will be easy, and on the other hand, you can just install your ICC profiles on your computer, so the profiles appear in the Adobe applications, whatever profile you install.
Okay, then we have the wrap up. Maybe I take over again.
Yes, please.
So thank you. So just to wrap up everything we heard today, what does this mean for me, or what does this mean for you? To make a long story short, the majority of standards will be adapted soon, or the changes are already in process. We have GRACO 2013, we have FOGRA 51, FOGRA 52. Actually, the most important part is clear communication. Make sure that everybody has the same viewing condition. create your proofs according to the new standard FOGRA51 or FOGRA52. The printers have to do one additional step. They have to adapt their plate curves according the new TVI curves as they are described in ISO 12647-2 in the new revision. So the really most important part is you need proper lighting. Make sure you have D50 norm light, or at least that everybody in the production chain has the same viewing conditions. This is so important to talk about the same color result, to talk about the same UC. And of course, the surrounding when doing color appraisals is important as well. So don't wear your red t-shirt. Try to wear more neutral colors. I think most of you know all these criteria. Sooner or later, it should be that you invest in a new measuring device capable of measuring M1. For now, at this point, you need an M1 measurement device when you want to verify your proofs. So when you want to measure the media wedge of a FOGRA51 or FOGRA52 proof, you need to use a measurement device which is capable of measuring M1, since the verification in another measuring mode is not allowed, since the target values are defined in this measurement mode. If you do new reference measurements, especially when optical brightness are involved, please use M1 if you already have a measurement device available. So a little more detailed look. If we have a look at pre-press proofing, what you have to do when you want to change to the new standards, actually you just replace your FOGRA39 with your FOGRA51. Means you download the ICC profiles from the ECI page, you replace your ICC profiles, you update your color server to have a conversion possibility from FOGRA39 to FOGRA51, for instance. Talk to your customers and talk to your suppliers and tell them, well, okay, send me your data in FOGRA51, or the other way around, tell your printer, oh, well, I want to send my data in FOGRA51. Did you already adapt your plate curves? So communication, this is the most important part. Actually, the same for the press, so the same for the printer. You replace FOGRA39 with FOGRA51. You update your color server to have the color conversion available. Talk to your customers, talk to your suppliers. So if you as a printer already adapted your plate curves according the new revision, just grab the phone, talk to your supplier and tell them, hey, I'm capable of printing with the new plate curves. Can you deliver me a FOGRA51 proof? And that's actually all you have to do. So clear communication, talk to each other, and then the change is not really a big deal, or it can be realized without witchcraft. This is a saying we have in Germany here. So it's really not that complicated to change to the new standards. We have a little sidekick. Maybe Jürgen, you want to say a few words about the print according FOGRA51 you did?
Yeah. Before it was really a struggling, because maybe just a very short historical view. When we started doing FOGRA51, we already started with an existing data set that one of the Heidelberg guys had made, which did not really fit the print, so we had to restart from scratch the BVDM. So several guys were very reluctant and didn't really believe. So there was a lot of struggle. But at the end, we really knew what is happening. We now understand very well M1 measurement. We understand OBAs. like we never did before. In the last 2 years, we had a learning curve that was tremendous. With this in mind, I tried to emphasize, and I finally got it, to have a big coffee brand house, a German one. They have all second week, they have a catalog, and they have a lot of stores all around Germany, and they have a catalog every second week. And I told them, okay, this is a FOGRA 39 production. Did you know that with FOGRA 51 we could do much better? So we were doing then pre-press according FOGRA 51. This was the first time that it was not released yet, FOGRA 51. It was a pre-release version, but it was the same. And the repro guys, they never knew how to handle this. We made OBA proof, proofing substrate, FOGRA 51 proofs, and we went to the printer. We were then doing 2-3 iterations to get the plate curve ready for the new ISO 12647-2 rules, and then we just printed a production. And the customer, he was so surprised, because he was really struggling. He didn't want to risk nothing, so he was really struggling all the time of preparation. Are you really sure? Is this going to work? Because we have this production ready, blah blah. At the end, this here you see his conclusion after this print run. It went so smooth. So for him, the downside was he couldn't negotiate, or he couldn't really argue anything, because it just, wherever he had to he could argue in the past, when the yellowish proof did not match and there was a smooth tint, as smooth as a shiny skin tone, whatever, which just didn't match on the OBA containing production stock. This was now just much smoother and better. So several printing productions since then. This was, I think, in July we did this print run, and since then I've seen several more, and this is now going to start quickly to be implemented. Asking the printers, I've just had a training session some days ago where we had in the academy a full day training session about this topic, going much more into detail with all the topic, with all the different areas. It's going to be a win-win once a printer knows how to handle the new standard. This is a good announcement for your print buyers. Once a print buyer starts to deliver the new data, he will get better comparability between his pre-press color talk and the final product, and this will also be an immediate push to the printers to change to the new references. So for me, this seems to be going pretty fast, that the implementation starts now.
Thank you, Jürgen. So if you have additional questions, it's now the time to ask them. We already had a few questions. And while you're thinking if there's anything else we can answer, I just want to inform you, Jürgen just mentioned it. We do these trainings as a full training day here in Tübingen at the Academy as well, in English. The next training in English is actually next week, so I know very short notice, but just for you to keep in mind, just have a look on our website, what we have in our training portfolio. If you have other requests for training, maybe for colleagues or whatever, just contact us. Actually, we can train you about almost everything about color. So just feel free to drop us an email. And yeah, so for now there's no more questions coming in. So thank you very much for your attention, and thank you very much for your questions as well. And as I just said, materials and recording will be linked in the follow-up email you receive. So thank you very much, and have a nice evening or a nice day.
Thank you all, and a good digestion of the information. Have a nice evening, a nice day. Bye-bye.